Good morning, ma'am, and myself Harini, and my roll number is 234G1A044. And my branch is ECA section, and my subject is differential equation and vector calculus, and subject code is 23 Mat 02. And I'm pursuing first year BTech in second semester, and CA2 assignment. And topic is line integral. And today my topic question is evaluate the line integration x square plus xy into dx plus x square plus dy and x square plus y square into dy, and where c is a square formed by the lines x is equal to plus or minus 1 and y is equal to plus or minus 1. And again the given question and the limits also is given, and the question is x square plus xy into dx plus x square plus y square into dy, and this is all of 5. Slide first of all given is f bar dot the door bar is equal to x square plus xy into dx plus x square plus y square into dy. First of all, given curves in a square formed by the lines is a x is equal to plus or minus 1 and y is equal to plus or minus 1. And in a given question is a square is formed, so it is a square, so we find out the limits. First we draw the diagram, a square type, and first of all in a x-axis x is equal to 1 and y is equal to 1 on a point, and b point minus 1 comma and minus 1 comma 1, and x is equal to minus 1 and y is equal to 1, and at C point x is equal to minus 1 and y is equal to minus 1. So C is equal to minus 1 comma minus 1, and D is equal to 1 comma minus 1. So x is equal to 1 and y is equal to minus 1. It's a given limits, and f bar dot in the given question it is a square, so the limits is first of all integration ab f bar dot dr bar plus integration bc f bar dot dr bar plus integration cd f bar dot dr bar plus integration dA into f bar dot dr bar, and we can write the apply the limits and we can solve the problem. And next one, first of all along AB, first one along AB, and point is A is equal to 1 comma 1 and B is equal to minus 1 comma 1. In the points at this here the same points is y is equal to 1, and differentiate y is equal to 1 with respect to y, and dy is equal to 0 at the limits x is equal to 1 to x is equal to minus 1. Integration AP f bar dot dr bar is equal to x is equal to 1 to minus 1. Uh, in the limits, and y is equal to 1, and we can write the y is equal to the given question y is equal to 1 and dou y is equal to 0. So in this quotient and the dy term is also 0. So in the dx term and y is equal to 1. So we can write the x square plus x integration x square plus x into dx. So we apply the integration, and the x square is equal to integration x square is equal to x cube by 3, and x is equal to x square by 2, and we can apply the limits and upper limits minus lower limits. First of all apply the upper limits, minus n whole cube by 3 plus 1 minus 1 by minus 1 whole square by 2 minus into 1 by 3 plus 1 by 2. The minus 1 whole cube is equal to minus 1 and minus 1 whole square is equal to 1. 1 by 6 minus 5 by 6, that is equal to minus 4 by 6, and the divided by 2 cancellation of 2, and 2 2s are 2 3s are, so minus 2 by 3, and along the line segment and same point, and we can change the only BC. So at point minus 1 comma 1 and c is equal to minus 1 comma minus 1. Here the same points is x side x is equal to minus 1, in the b point x is equal to minus 1 and c point x is equal to minus 1. So we can write the same point is x is equal to minus 1, and so dou x is equal to 0. The limits is equal to y 1 to minus 1. So the integration bc is equal to f bar dot dr bar. Integration y is equal to 1 to minus 1, and the given question and the dou x is also term is also 0. So in the dou y term, and y is equal to minus 1. So 1 plus y square into dy is equal to integration 1. I mean integration 1 means integration dy is equal to y, and y plus y cube by 3. Limits is 1 to minus 1. Upper limit minus lower limit minus 1 minus 1 by 3 into minus 1 plus 1 by 3. So minus 3 minus 1 by 3 minus 3 plus 1 by 3 minus 4 by 3 minus 4 by 3, that is equal to minus 8 by 3. Along the line segment CD, and also at points is C equal to minus 1 comma minus 1 and D is 1 comma minus 1. In these points, C point y is equal to minus 1 and D point y is equal to minus 1. At the same point is y is equal to minus 1. So differentiate this y is equal to minus 1, dou y is equal to 0. At the limits is minus 1 to 1. So integration CD f bar dot dr bar is equal to integration x is equal to minus 1 to 1 x square minus x into dx. In the term dou y is equal to, and dy is equal to 0. So dou y term is all of 0. So y is equal to minus 1 in place in the dx. So integration applies. So x cube by 3 minus x square by 2, and limits is minus 1 to 1. Apply the limits, and upper limit minus lower limit 1 by 3 minus 1 by 2 minus 1 by 3 minus 1 by 2. So minus 1 by 6 minus into minus 5 by 6, that is equal to minus 1 by 6 plus 5 by 6 is equal to 4 by 6, and 2 2s are 2 3s, so that is equal to 2 by 3. And last one, along the line segments DA, at D is equal to 1 comma minus 1 and A is equal to 1 comma 1. In the D limit x is equal to 1 and A limits y is equal x is equal to 1. And at the same points is x is equal to 1, and I differentiate this term and dx is equal to 0. At limits y is equal to minus 1 to 1. Integration dA f bar dot dr bar is equal to integration minus 1 to 1, and dx term is 0. So we write the x is equal to 1 in the dy term and y 1 plus y square into dy, and apply the integration, and integration dy is equal to y. So y plus y cube by 3, limits is minus 1 to 1, and 1 plus 1 by 3 minus 1 minus 1 by 3. 4 by 3 plus 4 by 3, that is equal to 8 by 3. And then from given equation, this equation in the we write the we prove the solution along the AB minus 2 by 3, and along BC minus 8 by 3, and along CD 2 by 3, along DA 8 by 3, and all are substituting this equation. And integration, see, I mean f bar dot dr bar is this nothing but x square plus xy into dx plus x square plus y square into dy. So all are substituting values, and that is equal to minus 2 by 3 minus 8 by 3 plus 2 by 3 plus 8 by 3, that is equal to 0. Uh, the integration of f bar dot dr bar is equal to 0. Therefore, integration of bar dot dr bar is equal to 0. And thank you, ma'am.